So it's simply to say welcome to the 19th Rodolfo De Benedetti lecture. We are very happy to have today with us Ed Glaeser to present a lecture on cities and infrastructure. Let me say, though, that to some extent, Ed has been already with us in this series because in 2002, our friend Alberto Alesina had presented the lecture that was in comparing welfare states on the two sides of the Atlantic. And that lecture then gave inspiration to a book. The title of the book was Fighting Poverty in the US and Europe, A World of Difference, published by Oxford University Press. And that book was really something that was very influential. Is the best, the one that had more impact, by all means, of a series of a Rodolfo De Benedetti lecture. And that book was co-authored by Ed Glaeser. So in a way, is for Ed also to come back to the series, and that makes us even more happy to have him today with us. But I don't want to take any time off Jan Bakker, who will now say a few words to introduce Ed. And then Ed will give the lecture that will last about 40 to 45 minutes. And then Luisa Gagliardi will introduce the discussion. But during the presentation, please, if you agree, Ed, feel free to ask questions if there are things that need to be clarified. As Ed has an attitude to speak quite fast, let me say so, you promised to go a bit slower today, but in case there are things that you don't think are enough clear and so on, please feel free to interrupt and ask questions for clarification. So Jan is a colleague of ours at the Department of Economics, and we are very happy for him to take, to present, to do the initial introduction.
Yeah. All right, thank you very much, Tito. And well, it's a great pleasure to be here, and welcome to tonight's lecture. It's really an honor to introduce our speaker, Professor Ed Glaeser, who really doesn't need any introduction. He is the Fred and Eleanor Glimp Professor of Economics at Harvard University. He also leads the Urban Economics Working Group at the National Bureau of Economic Research. He co-leads the Cities program at the International Growth Center, co-edits the Journal of Urban Economics, and well, I could really continue listing other things he does for the profession and other memberships he has for the next 15 minutes, but that would take valuable time away from him. So let me just say he's a member of a number of scientific bodies and has received a number of awards for his work. I think to the general public, he is probably best known for his book, Triumphs of the City, that The Economist called the most important book on cities in decades. Among economists, he is really known as, and widely regarded as, one of the defining figures, one might say the father of modern urban economics. And over the past 3 decades, I would say he has revitalized and reshaped the field of modern economics and has changed how we think about cities, housing, infrastructure, and the deep connections between geography and economic development. His contributions to urban economics are both foundational and far-reaching. In fact, after tonight's lecture, I might set you the task to find a subfield of urban economics that he has not contributed to. I tried that today and I couldn't find anything. So let me just say he has contributed to the study of agglomeration economics, showing how cities thrive as engines of ideas exchange and innovation, and grounding these empirical insights into economic models. He has also provided deep understanding of the role of housing supply and housing supply constraints, such as land use regulations, for determining cities' growth and decline. He has written influential works on segregation and spatial inequality, the economics of crime and public services, and how they shape urban outcomes. Time and again, he has returned to a central theme, that cities, above all, are made by people, and that policy should focus on empowering those people, not preserving existing structures. And in doing so, he has redefined the questions we ask about urban life and the tools we use to answer them. And yet, his intellectual reach goes far beyond urban economics. My advisor, Tony Venables, once described him to me as a Harvard academic in the fullest sense, restlessly curious, analytically rigorous, and unafraid to cross disciplinary boundaries. Coming from somebody who's itself an Oxford Don, to me, that was the highest praise you could give. Now, Ed's work bridges economics, history, political science, architecture, and moral philosophy. It's always intellectually ambitious, but never abstracts for abstraction's sake. What makes his scholarship so compelling and unique to me is not just its breadth or precision, but its humanity. He doesn't study cities in the abstract, but studies how people live, how they work, and how they succeed in cities across the world. Now, listening to Ed has always been an inspiration. And so I was wondering, when was the first time that I actually made this experience? And it was a couple of years ago. I sneaked into a small NBER workshop as a PhD student, where you weren't really supposed to be. And so in this workshop, each paper had two discussants. There was the assigned discussant, and then there was Ed, who somehow was able to provide sharp, generous, and insightful commentary on every paper. And that experience left a really lasting impression on me, and continues to inspire me today to be curious, to ask the big questions, and to, well, keep going even at the times when, academic research doesn't quite do what you think it would do. And has a remarkable ability not only to lead, but to inspire, to energize students and young academics, to make them feel like their questions matter, and to show by example what intellectually engaged scholarship can be. So we are incredibly fortunate to have you with us tonight. So please join me in welcoming Professor Edward Glaeser.
Thank you. That was amazingly kind. That was amazingly kind, and I'm incredibly grateful. It is, both an honor for me and sort of emotionally important because of its connection with Alberto. And the lecture that he gave 23 years ago both built on an earlier Brookings paper that we had written, and then turned into a book that in fact was, of the books that I've written, after Triumph is the book that I'm most proud of having written. So it's great to be back here at the De Benedicti lectures. Two things, one of which is I will be giving you a collage of papers, okay? So by all means ask questions, but don't worry terribly much if you didn't understand this coefficient or that coefficient, right? My goal here is, particularly with the graduate students, to get you excited about these topics, right? And to try to convince you that it's worthwhile, like figuring out how to write a better paper than me on this topic, which is always my goal, not that you critically understand exactly what I do. Secondly, and this is even more important, and I will particularly look at my co-author back there because it's your job above all. If I am going too fast, and this is a great curse of mine, right? Put this sign up, this T, okay? But anyone can do it just to slow me down, right? Because otherwise it may get lost. Okay, so with that, let's get started. Okay, so I often argue that cities are best thought of as a three-legged stool, as a tripod, where there are three critical ingredients. The first of which is the magic of human interactions, which I have pictured here in the old city of Jerusalem there, sort of the ability to buy, to sell, to learn from people, to work together, to make a friend, to do all sorts of things. And the first part of this talk will talk about those elements in cities, which I think of as being critical to the learning that goes on in cities, critical to the innovation that goes on in cities, critical to cities being places of upward mobility and opportunity. Second, right below it, is the fact that there are also demons that come with density. If two people are close enough to share an idea or a smile face to face, they're also close enough to give each other a disease, right? And the same urban proximity that facilitates urban markets also facilitates theft, right? Traffic congestion is a fact that bedevils all of the large cities throughout the world, and there are more. Finally, of course, there is the physical city, and as was suggested, right? I've always argued that real cities are made of flesh and blood, not concrete and steel. But of course, the concrete and steel also matters, right? Our buildings, our infrastructure are the stages in which we live out our lives. They enable and empower people, or they make things difficult. And so we will be talking about that as well. What I will not be talking about today, right, is I will not be talking about housing, because I talked about housing yesterday for most of the talk, and I will be talking about housing in Torino tomorrow. And if you really need more of me on housing, there exist 1,000 videos on the web where I'm talking about housing supply constraints. Okay, so I'm going to start off by talking about human interactions, then I'm going to morph into the physical city, and then I will morph back into some work that's actually joint with some architects as well to cater to our architectural friends work. So let me start with the De La Rocca and Puga version of my learning and city model. So about 30 years ago, I wrote a paper that got published in the Journal of Urban Economics in 2001, and the Journal of Urban Economics in 1999, and the Journal of Labor Economics in 1991. It got split up. The model is in the Journal of Urban Economics. It is a model in which we go through life running into people who know things that we don't, and with some probability, we learn what they learn. Okay, which is, of course, why it's always important to hang out with smart people, right? This is how we acquire human capital in life. And we learn occasionally from the people around us. Now, this has implications for urban labor markets, which is we think of people coming to cities and then experiencing a different wage trajectory. And when I first worked on this stuff in the early 1990s, I was restricted to using the non-institutional data that was available, data like the panel study of income dynamics and the National Longitudinal Survey of Youth. This is kind of crappy data for doing that, right? The sample sizes are small, the number of movers you have, and if you try to estimate an AKM model, for example, over space using one of these, it's just a nightmare. You just don't have enough observations to do it. Luckily, De La Rocca and Puga had institutional data from Spain, and they were actually able to estimate treatment effects of place. And as we found in the US, we didn't just find a level effect of place. We found that big cities were associated with a higher slope associated with learning, which was compatible with the famous Alfred Marshall quote that the mysteries of the trade become no mystery, but are, as it were, in the air in dense cities, compatible with the view that cities have a learning effect. And you can see sort of Madrid has a steeper slope than Sevilla. And, you know, if you stay in Madrid, you continue to get the slope, but there's also a level effect that you get from moving. And that's, I think this is a nice graphic for understanding what goes on in this stuff. So we're estimating both level effects and slope effects. I do nothing new methodologically over what they do in their restud paper, but we took it to a different context, which is Brazil. One of the big questions about is whether or not the sort of, they're poverty traps or also places of upward mobility. So if you look at Mark Stoker and Suri's Journal of Economic Perspective paper, they look at people who are long-term residents of developing world slums, and they typically find people are trapped in poverty there. At least they appear to be trapped in poverty there. Now, the downside of their work is they're looking at a cross-section. They're actually not looking at a panel. And the cross-section, the obvious selection of the people who are staying in the slum 30 years after they come to the city would lead you to be very doubtful about whether or not you could believe that kind of effect. And so Brazil is about the poorest country that exists where you can actually have institutional data that is far-reaching enough for you to trust it. The problem is with places that are poorer, the informal sector just overwhelms everything. But among sort of, younger age Brazilians, you get to 80% of the population. And so there's a bunch that we do in the paper to obsess about the informal sector and moving in and out of it. But I wouldn't want to go poorer than this with institutional data because you just couldn't trust what you're learning from this. These are the microregions. And as you can see, there are big differences in income. In particular, the South is much richer than the North, and this will come up repeatedly. And the first thing that we're doing, and again, this is the poor man's version of the dynamic estimation, is you just look at the cross-section and you look at the interaction between how long you've been in the labor market, your age, or age minus education minus 6, and then you look at the interaction between that and city size, and you ask yourself, is there faster slope there? And the answer is there is, right? And there is not just in the institutional data, but here we actually have workers who are not institutional. And so here, this is actually only has 6 metropolitan areas, so it's positive, but you can't really tell very much. This is a much larger set. And these are unfortunately only a cross-section, but this has the informal workers. And what I like about this thing is it just shows you that with this simple test, which is less good, right, the informal workers have a slope that's actually higher than the formal workers with age. So there's no evidence to suggest that there isn't upward mobility over the life cycle for the informal workers as well. But the bulk of work that we're going to do uses the De La Rocca and Puga methodology, which just looks at workers as they move around and estimates this with the worker fixed effect. And we're doing exactly their kind of thing. There's 10-year effects, and there are like 15 more coefficients that go down that I'm not including here. But so we're estimating both a city indicator effect, and we're looking at how long how long you've been in it. So experience in the first to second largest urban areas, experience to the third to fourth largest, experience in the fifth to seventh largest, and so forth. And we can do this for both all men and those men who are initially poor. So we select only the sample who are initially poor. And overall, if so this is the elasticity with respect to city size that these specifications imply. So you've got a slightly higher effect for the medium term. This is this initial plus 7.7 years. It's actually larger for the initially poor. And it's a number that's slightly smaller than the Spanish number, but still fairly considerable, right? So this is an elasticity with respect to city size, which is like 0.04. The US number would be like 0.05 or 0.06, something like that. And the initial poor people have, if anything, a slightly higher slope, which is compatible with the view that the cities are in fact providing pathways out of poverty for poor people in Brazil. Now, when you look at the differences across Brazilian cities, so the initial premium, this contains an is-north dummy and an is-north interact with population. This is the thing that jumps out at you, okay, is the difference between the north and the south. And it's not just, at least for the initially poor, it's not just the level effect, which is huge, right? But it's also the interaction with the age, especially with a large city, especially for here. So look at, there's a difference between slightly larger, medium than initial, okay? And if you look at the sort of, when you interact this with north, it's only going on in the southern cities, right? The northern cities are not providing any form of a medium-term effect. It's all going on in the south. And in some sense, the larger riff of this paper is to try to understand what could possibly be different between the northern and the southern cities. Why are these southern cities ones in which you do have this medium-term effect, but in the northern cities you do not? So bigger cities in the south are not doing anything particular in the medium run. And even here it sort of becomes easy enough that you can't really tell. Now, this is just regressing the medium-term premium on city size and then a number of other variables. Oddly, in Brazil, the share of college graduates, which works magic in almost every wealthy world regression that I've seen, actually comes in negative once you control for these other things, which is kind of bizarre. What looks like it is happening is there are a bunch of particularly northern cities in Brazil which have large numbers of college graduates who are not in the private sector. They're actually, and so this includes everybody. We could have redone this, I guess, in the private sector college share, but we included everyone. And these places don't appear particularly functional. They do fantastically well if you have a public sector job in these cities because they're relatively cheap and the public sector kind of pays the same thing everywhere. And so the public sector, well-educated people in these Brazilian cities are actually doing very well. But certainly this effect, this is north effect, which you can see here is sort of minus point, we're doing the medium term, so it's minus 0.16 here, minus 0.157. It drops a bit, but it doesn't drop a whole lot. This was a measure of just complexity, just how complex the industry is. That causes it to drop a little more. But the thing that really kills it is this measure, which we just tried as we were trying things, but we tried because it was specifically implied by the model, right? So a model in which you learn by interacting with people tells you who you work with, whether or not less skilled people work with more skilled people, should be quite predictive as to whether or not the city is providing a pathway out of poverty. And this measure basically kills off the is-north dummy. And if you want to visualize it, this is kind of what it looks like. So the red is the south, right? Because it's on top. The blue is the north, okay? And so you see when you control for city size, like the south is like right on top of the north. So the southern cities are just doing much better overall. This is the initial premium. It would look the same if you used the median premium. But when you control for the exposure measure, low skilled to high skilled, right? You basically kill off this effect. And so to me, at least, like there's nothing necessarily that I've gotten causal right now, and I'm going to show you a little bit that we're able to do in the US in causal, but this at least raised the hypothesis to me that segregation of the workplace is a really central thing for us to understand. We've had 60 years of study of segregation at the community level, right? 60 years of thinking about whether or not the separation between African Americans and whites or rich and poor, educated and non-educated in where they live, like looking at that. And yet, for most of us, we're not learning when we're asleep, right? We're not actually engaged in the process of building a career when we go home. What matters is who we're around at work, right? And this is sort of, while both blindingly obvious and something that like there isn't a literature on, and there should be a literature on. And so that's in some sense what this is going to be a riff on. Now, this is sort of suggestive that this matters. We then try within the Brazilian context to explain why this is different. Next slide. Okay, but we don't have anything that feels exogenous on this. And so they tend to have in the North, I just highlight, the Northern firms tend to be simpler. They tend to be natural resource related. They tend to be smaller. So my mental model is one in which a sort of extractive world that characterizes the Northern industries leads to relatively simple firms where less skilled people work with other less skilled people and they don't find pathways out of anything, right? Whereas the Southern cities are kind of like European cities, right? And they've got lots of different firms. You've got lots of less skilled people who are working with more skilled people doing lots of different things. And so that workplace integration enables the sort of upward mobility that we actually see in this data. Okay, switching to the US. So this is joint with Frankie Dillon and Bill Kerr of Harvard Business School. And so we're able to use at least still for now, we're able to use the full count of the economic census data. So we're actually basically looking at all the businesses in the US. And the first thing we're going to document, this is in an AEA Papers and Proceedings that was out this year, is the rising segregation of college and non-college educated workers in the US. Now, it's not like it's going from 0.4 to 0.7. It's going from 0.252 to 0.55, okay? So it's going up. And this is the standard dissimilarity measure, which has the meaning, what share, you can move either one of the groups, what share of less educated people would you have to move across establishments in order to have a completely flat distribution of educated people across the years. So that's gone from 52% up to 55%. In our P&P, we worked through a bunch of different explanations for why this is, so I refer you to that, but that's not my primary reason for putting this up. This just shows you the gap in upward mobility for non-college educated workers in different industries when they are in an establishment that has an above college educated share in that industry versus below college educated share in that industry. You can see in all of them there are gaps. I'm particularly struck, I have no idea what this means, but protective services is the largest gap. This means like being bodyguards or being security guards in different ways. You can look at it, I don't know what it means. What we have been trying to do, and you can do this both for just overall all skills, so the moving of educated people into less educated places, but you could also do this with more stuff about occupations and like try to understand better whether or not people go into higher ended occupations when they get dosed with people for the particular occupation. So we have a bunch of different experiments. Now, none of our experiments are like super clean experiments, but they all sort of show the same thing. So we have a bunch of different designs, which are movers, stayers, and block levels all have the same feature. A significant number of people are moved into an establishment. And it's sort of, you can play around with different sort of mass moves, but you move a mass and then you can look either, was I part of a group that was moved, where you sort of think that if you have more than 15 people are moved, this is likely to be a corporate thing, not necessarily about you, but still it's probably true that if you were part of this move, there might have been something special about you. So the movers, right? The movers, and you can ask, are you part of a mover who saw the education share go up a lot, or were you a mover who saw your occupation share go down a lot? So we're all comparing movers who went up versus movers who went down. Or you can look at stayers. So stayers get dosed with the dose of movers. Okay, and so did their stuff go up? Did their stuff go down? And all of these things show the impact on the difference between a positive shock and a negative shock. Then you can look at the block level. The block level is a little bit weaker. What this means is, it's not your establishment that got shocked. There was something on your block that got shocked that's outside your establishment. So you may think that's a little cleaner. That also has a positive impact. And then the last thing, which I think is the least clean, is you were liquidated, and then did you end up moving to an establishment with a higher or lower education share? And you can see that's much larger, and I think probably because I think that's the least clean of those things. But they all show kind of the same thing, which is if you got dosed with more educated peers in your establishment, right? You see your earnings go up significantly over the next 10 years. And they go up in sort of a relatively linear way over time. And again, compatible with the view that the people that you work around influence is your upward trajectory. Okay, first two papers are on firms. We're going to stick with the topic of daytime interactions, but now we're moving to kids. Okay, so now I'm going to move away. I'm going to move away from workplace interactions. I'm going to move to interactions in the household. First fact that I want to motivate this is This is a well-known graph. This is the agglomeration economy graph. So this is the link between per capita productivity across America's metropolitan areas and the overall average density of the area. So that's positive and well known to be positive. Along the other side, I have upward mobility. So this is Raj Chetty's data. This is where you end up if your dad was at the 25th percentile, if your family was at the 25th percentile, where do you end up as an adult? Across metropolitan areas, it's a straight negative line. Okay, and so this begs the question of like, why is it that cities seem to still be quite good for economic outcomes for adults and crappy for economic outcomes for kids? And this is true, this is across metropolitan areas, but the same fact is true if I compare more dense neighborhoods within metropolitan areas, right? Again, bad for kids. If I compare kids who live close to the city center versus kids who live away from the center, again, the more central thing is bad for kids. Or if I just take the regression discontinuity at the edge of big city school districts, that's, again, sort of a big negative thing if you're inside the city versus outside. So what explains this? So my hypothesis remains, again, mixing, again, exposure. And again, my sort of intuition is that the adult that like wakes up in a segregated neighborhood goes to work in an integrated firm. The kid who wakes up in the same neighborhood, plays in a segregated neighborhood, goes to a segregated school, is basically as isolated as they would be if they lived in a rural village. And so that's the hypothesis on this. Now, it turns out my first brilliant idea is, why don't we just get cell phones for kids and cell phones for adults, and we'll compare this. And that was where the paper started. And it's joint with Lindsay Currier and Cody Cook, and it follows earlier work by Susan Athey and her peers. The problem with this is that because of this, like, oh, we want to like protect kids' privacy, none of the data sets have anybody under the age of 16. Okay, which, as you can see, makes this research design very difficult. Now, I can then take all of the people and separate out those who spend significant time during the week at schools, right? Because I can identify where the thing lives. Okay, that's great. So I get whoever is 16, 17, 18 in this data set and in these schools. But I also get every teacher, every custodian, every administrator, right? So I'm highly diluting it. Now, when you do that, yeah, it's true, the students are more isolated than the adults are. And so if you measure this exclusion, the segregation measure, excluding time at home, you go from like 0.31 in isolation index to 0.37. The income isolation rises more slightly. So there is a difference. And all of this exposure to different stuff, it's lower for the students, but none of it soars in a way. And I think part of it is bad measurement. So let me do a different measure for you, which I think is more, I can also look at adults versus students and like how many unique locations they go to. The adults actually goes down much less than the students do with population density. So that's kind of indicative of something. And of course, as the adults live in more dense areas, they spend more time at work or school and the kids spend less. But let me show you the other thing, which I think is much neater that we do. And Cody really deserves the credit for this, because Cody takes the cell phones and he links it to the value of the home. So you can do that since you know the exact addresses. And so if you think the value of the home is highly indicative of the permanent income of the household, we can then sort of line this up with the income distribution. And then we can just ask, how does mobility behavior change? And this is for kids. I can do this for adults as well. How does it change as I compare rich versus poor? So the paper morphed from being how different are adults versus kids versus how different are rich kids and poor kids, because I think I got that, or rich kids plus custodians and poor kids plus custodians. And the answer is it's pretty darn different. So, this is visits to different things. So different amenities, entertainment, retail, restaurants, parks, how far they roam. The unique places visited just goes up with income. Distance from home actually is an inverted U. This is time spent at primary locations. At time spent at home goes down as you get richer, right? So in fact, the poorer kids are spending more time at home. The richer kids are spending less. And of course, this is, I think, in some sense, captures the essence of the city. So this is how many of these different amenities you go to. Now, maybe we're not surprised that the richer kids go to more entertainment venues. Maybe we're not surprised that they go to more retail shops. The fact that they go to more parks, though, is particularly amazing, right? These parks are all free. There's no income reason why they couldn't go to the parks. And yet the difference is like, this is a coefficient of 0.4. So they're going to like 0.4 log points, more parks than the poor kids are. So it's a strikingly different relationship to the urban space that's associated with being rich versus being poor. Okay, and so this is the end of the interaction part of the course. Hopefully I've managed to keep myself slow enough that you're not, the intermixing things, you're not either completely bored or completely lost. But so this has been, and I'm now going to move to urban infrastructure, but of course it's urban infrastructure that relates to mobility. And so in some sense the two things are linked because they're both about getting people around. Okay, so this paper is called Infrastructure Inequality. The original title of it was How Rough Are America's Roads? Evidence from Uber. That had exactly like 3 downloads. We changed the title to Infrastructure Inequality and we had like 40,000 downloads in 90 minutes. So it was strategically chosen. But there's a real reason for this, which is we're unclear about the quality of America's roads. We're unclear about the quality of Italy's roads too. I mean, so there's a rich thing in all of this. And there's a sort of puzzle that's set out. This is a paper that was published in a handbook of infrastructure that I co-edited with Jim Viterbo from about 5 years ago. And there are 2 facts, one of which is the American Society of Civil Engineers hands out grades to America's highways. In the 1980s, we were doing okay. We were getting B minuses. For most of the last, and that's what that 2.5 means, that's a B minus. For most of the last 20 years, we've been getting like D minuses and stuff, okay? And no, that sounds terrible, and every time it comes out, it's like how terrible American roads, and the American Society of Civil Engineers says we need to spend $5 trillion more on roads to get America's roads better. But here's the problem. The Department of Transportation has been sending out trucks at 3 o'clock in the morning, armed with accelerometers that measure roughness. And as you can see, so this is the International Roughness Index, at least between the early 1990s and the 2000s, our roads have gotten a lot smoother. At least our highways have. And now, you might even think that the American Society of Civil Engineers was a lobbying group that was trying to get more spending on civil engineering, which lead me to think, why isn't the American Economics Association declaring that America gets a D minus in education, in economics training, and saying that we have a $5 trillion gap in how much education in economics that we need to deliver? But there is at least a saving grace for this, although this is supposed to be about highways. And I can't say this, but certainly in my daily drive, like the drive on the highways is smooth. But as soon as I get off the highways, it's awful, okay? And so maybe there's a certain truth to this in the sense that the highways are fine, but the rest of America's roads are terrible. The problem is we haven't been able to measure this until now because the Department of Transportation in the US, the federal agency, funds highways. It does not fund local roads. And so we did not have data until now. And what I had, because of the hours that I spent advising Jonathan Hall before he became chief economist at Uber, which is a reminder of all of your obligation when you're out and successful in the world to give your advisors stuff like really cool data. I have data. I have a full month of Uber data for the entire US in 2021. And I have Chicago, both April 2018 and over a longer time period. What Uber gets is something like 5 times per second. They get beamed back data from the cell phones, and all of our cell phones have accelerometers. It's what enables the screen to change when you move the thing. And so, it measures the bumpiness of the trip. Now, we've had to then map to road segments. And for the Chicago data, we spent a lot of time hand curating this. And so the map is really quite good. For other roads, it's less perfect. Now, what we're going to do for each of these things is when the DOT does this, they can send out their trucks at night, and there's the same trucks with the same measure going the same speed, right? Uber drivers are not so accommodating, right? They have different cars who drive at different speeds, and so there's lots of variation in bumpiness that's created by that stuff. So we run regressions for each road segment where you have a driver fixed effect, road segment fixed effect, so that's the mu r, a road segment speed term, which is forced to be linear. And we think that that's a reasonable assumption. We have lots of tests in that, and I'm not going to go through this here, but we think that's not bad. And then we have other fixed effects. So we've got driver fixed effects and date fixed effects and hour fixed effects. This is very, very dense data. So it's fairly easy to do this. And we're going to estimate fixed effects for 8.2 million road segments covering 516,000 kilometers of roads. We're going to do this all at a fixed speed. So we're going to hold the speed fixed at slightly lower speeds for roads than for highways. And I'll just show you a little bit that we tried to do to try and vindicate this. So just for example, this is what Chicago looks like. We have local roads at 20 miles per hour, arterial roads at 32, and highways at 48. And so one of the things that I want to highlight from this is that the roads in Chicago are a lot rougher than the roads surrounding them. Okay, and in fact, it's pretty discontinuous. And so that's going to play a role in our later estimation. Now, we do some things to try and show this. Now, first of all, we correlate where we do have highways and arterials, where we do have Department of Transportation data. We correlate our data with their data. It's like a 0.5 correlation. So it's not perfect, but it is what it is. We also have pavement condition index for New York City, which is a visual index, which is often what local highway authorities use in the US. And there the correlation is much lower. It's like 0.24. Here's the interesting thing though. When we regress speeds, and we're using the 75th percentile of speed in our data, and it's a sample of drivers who are not used to measure the roughness. So we split the samples, and whatever we do for speed is not what we do for roughness. Why do we do 75th percentile? Because like if you do below it, you're likely to get congestion. And so by taking the fastest quarter, we're sort of getting something that we think is relatively free of the straight congestion effects. Our measure, has a 33% R squared. When you look at it, their measure has an R squared less than 0.1%. And so their roughness measure is basically not capturing anything about how fast people are going, which suggests that, in fact, I think our measure is good and their measure is crappy, is what I basically believe. And when you put them both in, like our T is 20 and their T is 5. So it's not that it's nothing when you put them both in, but it's just a very different level of explanatory power. And so, like, would have been easier to tell if this was also a high correlation? Great, yes, but I kind of think that this is a lesson in actually using actual bumpiness rather than trying to use images and to infer the bumpiness from the images is probably sensible. To give you a view of what the US looks like, this is a map. The patterns are the sort of metropolitan area patterns. The patterns with climate look the same for the Department of Transportation data as it does for ours. Coasts are terrible. Inland is smooth. There is one thing. Remember, I told you we use driver fixed effects. So that makes it relatively easy to look across metropolitan areas because the same drivers go to different places. These drivers are not going to like different metropolitan areas with huge amounts. So I'm holding the mean of the driver fixed effects in the two areas fixed. And so you just have to accept that, like, if that's not true, and I think all the drivers in Tennessee have much smoother cars than all the drivers in New York, I don't know what to do about that. Okay, but you can see like big cities are worse, coasts are worse, Texas and Mississippi are really worse. Now, and I apologize to the architects, I'm going to put up some algebra in a second, not very much, but for the empirical exercise that's going to get at the pain associated with roughness, I'm going to try to translate roughness into pain. I'm going to be using the relationship between speed and roughness. And the idea here is, in some sense, how much you slow down at a salient break in roughness gives you your willingness to pay to get a smoother ride. Because you can always make your ride smoother. You get it by paying for it with time. So if I drive more slowly, I don't bump up and down as much. And so the extent to which people are willing to pay with time to go slower is going to give me a measure of how much they dislike driving. And so we're going to look at 137 Uber cities, which are basically metropolitan areas. That's got 2,641 towns and 3,905 border pairs. We're going to be restricting to around the border. We're going to instrument for the roughness level by roughness further in each town. And we expect to see the borders tend to be fairly salient, so we expect them to actually work in the way that they're expected to. We have we have other things as well. So this is towns. This is just the border effect. The border effect is smaller than the town effect. Unsurprisingly, this is Chicago with repaving events. So this is a smaller thing. And then this is railways. I don't know why we don't have a standard error, but we have railways for Chicago as well, which is another salient block in this. Now, the reason why you want this sort of border fixed effect is you want like other stuff not to be changing other than the roughness. And the problem is that other stuff can also change. We also control for speed limits, and speed limits are going to be useful actually in the full model. Now, and this is, for example, this is just the Chicago border, right? So these are not like, they leap out at you, right? So the Chicago border is a huge jump in roughness, boom, boom, and a huge jump up in speed, right? Everybody knows about the border. Everyone reacts to it. Okay, so what are we doing? How do we use this? Okay, so we're ultimately trying to get, so this is your driver's total cost. Driver's cost is going to be a time cost, right? So the V is the value of time divided by S times the cost of bumpiness times some K other costs. Ignore that for right now. But I'm going to be identifying this with changes in the speed limit. So you have to believe that this thing is, whatever these other costs are captured by the speed limit. Then you get this first order condition, which determines speed. And flat out use of the envelope theorem would give you that d cost d bumpiness is equal to the speed times b prime of gamma. So ignoring this, s times b prime of gamma is the same thing as ds d gamma, right? So you differentiate this thing totally and use first order approximations. It's equal to ds d gamma times gamma over s. So you get equal to the elasticity of speed with respect to the bumpiness. So the elasticity with respect to the speed with respect to bumpiness also gets you the sort of local treatment effect of how much the cost goes up with bumpiness. And so what we have to do is we piece this together at different levels of roughness, and with that you can integrate under the curve. Okay, so that's how the structure of the paper works. And then we have a little bit, it gets a little bit fancier when we use the other measure. So with this, we get to cost. And so we're using this derivative of speed with respect to bumpiness to get this. And this is kind of what it looks like. So you have a flat out speed per cost with no roughness, which is like 75 cents per mile. And then it sort of goes up with roughness. So the median roughness adds cost of 31 cents a mile. This flat 70 cents, this is coming from mileage and wear and tear on the car. Okay, so you're adding this extra 31 cents a mile is the median. One standard deviation higher road roughness is 23 cents a mile. And if we use the road resurfacing coefficients, which are smaller, the costs go up by about double. One thing, this is of course scaled by the value of time. Actually, I'm going to say 2 or 3 things. It's scaled by the value of time. We use $15 an hour. Typically, people use value of travel time as being something like half of value of wage. So we're thinking about a wage, maybe $30 an hour. If you're not happy with $15 an hour, you can multiply by any constant you want. I don't care, right? It's going to scale by whatever you want on this thing. Second point, this is not a social value. This is a value to the drivers. There are externalities involved in driving on rough roads, which may be either positive or negative. Positive ones are if you slow down, you cause less accidents. We can look at this, but I don't have, so I can actually tell you that the number of accidents are going down in rougher roads. It's actually true, but I don't have the denominator. I don't know about the total number of drivers on these roads, so I actually can't correct for that. But for sure, this is just getting you at the driver's pain, assuming the drivers don't internalize anything else. Okay, but importantly, they are internalizing this thing, and this is sort of a really critical thing. I don't want you to think that I'm just saying, oh, this is how much time is lost. That's not what this is doing. The model is telling you this is the total cost. This is like B prime of the thing. So it's using the time to infer the total cost. We're not just saying the time is the total cost. Okay, so the next thing we're going to do is show you, since I promised you inequality, I'm going to show you the relationship with race and income. So, this is income with climate controls. This is income with metropolitan fixed effects. It actually goes up. And this is income with town fixed effects. So why does it go up? I showed you that coastal areas have worse roads. So when I control for which metropolitan area it is, so it actually causes it to go up, because across metropolitan areas, the richer metropolitan areas have better roads. Okay. And about 2/3 of the effect disappears when I put in town fixed effects. This is race. Controlling for MSA does not do anything on this case, but controlling for town fixed effects gets rid of roughly 85% of the effect. And so there are big differences across the races in exposure to pain. So we estimate, using our measure, going from 100% white to 100% African-American neighborhood is associated with $456 per year of additional cost due to roughness. But 85% of that is because of towns, right? It's because African-Americans live in Chicago, not in Evanston, okay? And so you interpret that as you like, but certainly it's a substantial difference. It's not like everything, but it sort of feels interesting and important. This is sort of what Chicago, New York looks like. New York, like many big towns, actually has richer people living in places with the worst roads. And so the place with the crappiest roads in New York is Tribeca, which is filled with like people who are worth many, many millions of dollars. In part, that's because they have brick roads and they like it to have the brick roads, and in part because it's by design that they actually don't want people driving. In part, it's because people live in central locations who are rich, and those central locations are ones that get a lot of truck traffic, and hence they're crappy roads. And this just shows the interactions with metropolitan area characteristics. And again, smaller towns, richer towns have the steepest gradients with income. Smaller towns, richer towns have the steepest gradients with race. Okay, big cities have the flattest gradients. Okay, and so it's much more sort of in the small places that you see this. Road expenditure, and just a narrow, I'm going to control for roads, doesn't explain anything. This is not a natural experiment. This is just saying that the town fixed effect is not determined by rich places spend more on roads. It's assuredly something else. But again, I don't have some kind of natural experiment in this. What I have is the cross-sectional spending on it. So, and in fact, the places that spend more on roads have crappier roads. So as you might think that you expect to happen. Last point, and this is the only thing from this that I want to claim is immediate policy relevance, okay? Which is we can correlate how rough the roads are with how likely the road is to be repaved in the next 8 months. And the answer is, this is just 4 of them. Like New York, it's slightly more likely, okay? And that's true for about 3 cities in our 11-city sample. In 8 of them, there is 0 correlation between the probability of being repaved and the initial roughness. And so this is my starting message. I don't know how much we should be spending on repaving. I don't know what the right optimal level. You could use these calculations to help, but I kind of know you shouldn't bother to repave roads that are perfectly smooth. Okay, and so that's my policy lesson to America's cities and towns: is repave the rougher roads, not the smooth roads. Now you may ask, why is it that America's cities and towns are doing something as crazy as having the same probability of repaving the smoothest roads as they do of having the roughest roads, right? You may wonder why this is. And the answer is that the majority of them are repaving less than half of the roads that they say need repaving. And this is a very common feature with city governments throughout the world, which is they'll have a mandate. And so the mandate in this case will come from some engineering estimate, the pavement condition index. Like Boston has a mandate to inspect every one of its restaurants every year, right? How many of those restaurants do they get to? Oh, 30%. What targeting is there within that 30%? Oh, 0. Okay, so again, they've got some thing for PCI or something which is like every 7 years you're supposed to do this. Right? That's what our town does every 7 years, regardless of the current state of things. Like how much do you actually target within that? How much do you do anything? Not at all. And so the sort of largest lesson of this is just, you want to get the cities to be smarter on this stuff. And I think I used this last summer, and we'll make a larger point on this, which is a country that cannot manage to figure out how to pave its rougher roads first really shouldn't be in the business of planning industrial policy. So that's my larger message of this, that this is a considerably easier task than doing industrial policy, and yet we can't figure out how to repave our roads. Okay, last thing, I'm going to, how much time am I in? What's the, do you know how many minutes do I have left?
10 minutes.
Okay, so then I can say something about procurement. Okay, so two last topics. One is on procurement and one is specifically for the architects in the audience. So I will give you something on this stuff, which is again, returning a little bit to how we use public spaces. But procurement is one of my favorite topics, right? There are two major things that go wrong with procurement, one of which is regulation, one of which is corruption, the other which is overregulation. This is the famous Tweed Courthouse, okay, which was done in the 1860s by, the famously corrupt Tammany Hall regime of New York during that time period. At least 80% of this cost was pure waste, right? Pure corruption, just walked out the door, okay? In the wake of that, they passed a bunch of laws making at least the norm that you take the low bidder. And things got better, but over the decades, every time there's a scandal in New York, so in the 1920s, there was a scandal associated with Mayor Jimmy Walker, right? They come up with more regulations after that. But the weird thing about that was that what Jimmy Walker did was already completely illegal. But rather than thinking we need to enforce the laws, they thought, let's come up with another 37 laws that bind this. Same thing happened with the Donald Manna scandals in New York in the 1980s, right? Instead of what he did was clearly illegal, but they came up with more rules. And I think one of the interpretations of what that has done is created a system that is vastly overregulated, in which in some sense the political economy seems to value $1 of corruption as being worse than $1 million of waste. And you've created a system in which, this is from a paper that Jim and I wrote. So when we restrict our analysis to the 255 projects that are 100% in tunnels, the median cost of the 11 US projects is $1.4 million per mile, whereas the non-US global median is $341 million, right? We spend an enormous amount of infrastructure, and it's hard not to think that these rules have something to do with it. Now, when it comes to sort of, thinking about the regulations of government, I think it's important to remember that the regulation of private actors is typically set up as a battle between giving the private actor freedom to make decisions that maximize utility or maximize profits versus correcting some kind of an externality, right, of some form. That is not typically the problem with public sector corruption. The typical public sector corruption is the battle between, or public sector regulation, is the battle between the public sector actor being corrupt, getting some private sector payment for something, versus limiting the private sector's actors' ability to find a better deal, to structure a smarter auction, to bring in some other bidder. Okay, so the trade-off is, and in some sense, the optimal regulation of government, and this is sort of comes out in the model that we have in our AER paper from about 5 years ago, depends upon how aligned the interests of the procuring entity bureaucrat is with the public sector. And so in places like Sweden or Singapore that we think are really sort of global leaders in this, their basic model is they have very good people who are by and large aligned with public interests, and they don't regulate them very highly. They basically tell them what you would likely to do if you were running your own company and you had good people, you would hire great people and you'd say, figure out how to do procurement properly. Whereas the poorly performing places are much more likely to need lots of regulation, because if you don't have regulation, you have what Tweed did, and they just stole all the money. Okay, couple of things. So this is from a new paper where we've collected characteristics on 180,000 commuter coach cutaway buses from 2000 to 2004. We've got 3 databases, National Transit, APTA, Freedom of, we've FOIA'd 200 transit agencies from around America. 3 facts, okay? One of which is we have an astonishing number of buses where there's like only 1 bus in the database, okay? So like I'll show you the graph on that. America's areas are buying an astonishing number of completely bespoke buses, right? The ones that we see a lot of, like they can be expensive, but they're much more likely to be some kind of normal price as opposed to these ones that balloon. If you just look at the share of buses that are unique in data over time, we've gone from about 50% at the start of our sample to like over 80%, right? So 80% of the buses being bought in recent years are completely unique in our sample, meaning there's no other bus that's identical, okay? What this is associated with is enormously high costs. So the typical American electric bus costs about $1.05 million in our sample. You can buy a perfectly nice 36-foot electric bus from Kia for $350,000. So this is 3 times you would get if you bought like, if you bought from Amazon, essentially. If you bought like rather than, and when you think about it, the rules the Department of Transportation puts in place that you have to like send out a request for proposals, let all the guys compete, like they're guaranteed to sort of really hamstring the way that you do stuff. It's like I told you, you can only buy a car by sending out a request to like the 4 largest car makers and saying, I'd like to see your bid on creating a family vehicle for me with four wheels. And oh, by the way, you must source these inputs from these different companies, right? And so you've sort of micromanaged it through the regulation of this, and you get this sort of very crazy system. This comes out of an earlier thing, which is our AER article, which is the World Bank Procurement Survey. It was a potential new component. It was only done once, though. Correspondents, lawyers, et cetera, asked globally about how a hypothetical $5 million road construction project. They're asked about laws. They're asked about practices. They're asked about how process. They're actually about how frequent bribery is, how frequent are cost overruns, time delays, low quality jobs. We have a model where there's essentially a battle between the advantages of having a free procurement entity who can actually like throw out a crappy bidder if the bidder is sort of low quality versus having an unfree one who has to accept a low bid. What we get is, these are the 4 more or less true implications of a model. Regulatory laws, whether in rich or poor countries, that reduce procuring entity discretion do in fact reduce bribery. It just happens. Practices are better than laws when accountability is high and worse when accountability is low, where accountability is just measured by WGI, government effectiveness, or national human capital. Process and product improve regardless of the laws in more accountable countries. And regulation tends to be good in low accountability countries and bad in high accountability countries. And by good and bad, I mean it's just positively associated with crap. We don't have any, Esther made us take all the regressions out of the paper, so we weren't even hinting at anything that was causal. But this is just, the laws are better than the practices in above median human capital countries, and it's typically pretty big. And the laws are much, the practices are much worse than the laws in low human capital countries. This is just interaction, sort of everything, like the laws are bad in all the high human capital countries and good in all the low human capital countries in a non-causal thing. And then this is just like our survey, our overall product outcome. Positive laws are good in low human capital countries, bad in high human capital countries. And so again, you sort of want the optimal level of regulation of your procuring entity. And if you have relatively highly functioning bureaucrats, you want to leave them alone and tell them to do good stuff. And if all your bureaucrats are going to steal like mad, you want to restrict them. Last thing, and this is joint with Carlo Ratti, Salazar Miranda, and many others. This is for the architects, okay? And this takes us back to interactions. And what we have here is we have data from 1980 and today of movies. And these were movies made by a remarkable individual in 1980 called Holly White, who is famous for, among other things, when he was an editor at Fortune, he discovered a young woman who was a remarkable observer of urban life named Jane Jacobs. And he gave her a platform, and that platform led eventually to the life of great American cities. He also spent, paid for by Rockefeller money, an enormous amount of time looking at how New Yorkers used the plazas that were encouraged by the 1961 zoning code and what you got out of them. So we ended up having movies for 4 locations: Bryant Park in New York, which is right near it's right back of the library, Chestnut Street in Philadelphia, Downtown Crossing in Boston, and the steps of the metropolitan area. These are like what the movies look like. And we, and by we, I mean my co-authors, particularly Ariana, as I would have not the foggiest idea how to do this, used like a bunch of machine learning techniques to measure what happens in these movies. And so compare the movies that were made 15 years ago. We kind of like the 15 years ago because like not everyone was looking at their cell phone all the time then. So we can sort of look at the pre-cell phone change. And we're able to measure different stuff. There's a little sort of model framework in the paper, which is mostly about, as the value of time goes up, we expect to see people sort of being more businesslike in the space. But it's kind of interesting what happens. So this is the number of people lingering over time. And so this is just the number of people who are spending more than a certain amount of seconds in each location. And that's sort of sharply gone down. It's gone down everywhere. It's particularly gone down in downtown Crossing, which once was kind of a social space, and now it's just transactional. You're getting through downtown Crossing, you're going down into the subway. And so that's the most radical change. The Metropolitan Museum is probably the least change, right? So those steps still remain a place where people interact with other people. This is speeds. And so this is overall speed. So this is meters per second. So it's going from about 1.22 to about 1.4. So it's a non-trivial and statistically significant change. So we're walking through these areas much more quickly. This is the speed variation. Speed variation is going up, and you can see these plots as well that sort of show the differences across space. And again, it's downtown Crossing that really shows a substantial change. We are also able to look at how there's a shift in sort of people forming dyads or triads, so people being together and not over space. And so you can see the places where dyads are going up is Bryant Park, which has gone from being a much less safe area to being a much safer area. And of course going down in downtown Crossing, which again used to be a space that existed versus not. This shows how many, the churn rate, 1980 and 2000. So this is the share of people who leave the movie after this number of seconds. And then we can look at people forming groups and how many groups are being formed over time. And so you can see that that's also changing. So in 1980, we just had many more people forming groups than we do now. So that's sort of gone down, and you can look at how that's changed over time. So that's it. But and I'm glad I ended on the last one, because the last one is just like, I don't know exactly where this is going, but our ability to measure how people use space and interact with each other is just totally different. And this means that there's a space for like cooperation between economists and architects that never existed before, because the stuff we measured was typically not what they cared about very much. But we now can. And for all of you who are young, like study of cities, has been an incredible way for me to spend my life, right? And those problems have not gone away, and the upsides have not gone away. I've not talked a lot about the cities of the developing world, except for starting with Brazil, but there you have an enormous amount of both upside, like pathways out of poverty for the poorest people on earth, but also challenge of climate change, challenge of being caught in poverty, challenge of lots of other things. And so it's an incredibly rich area for all of you to think through. And I hope at least some of you decide that this is as fruitful and rich and interesting an area for you to do work on as I find it for in my time. So thank you again for including me in this year's debate at Edgewood.
Okay, so let me first of all say that it's a real pleasure to have the opportunity to make some reflections on Edward's work on cities and infrastructure. And being myself trained as an economic geographer, I got exposed to Edward's research from a variety of perspectives. So what I will take today is the point of view of a broader epistemic community, because I really agree with John that one of the defining characteristics of Edward's research is the capacity to break boundaries across disciplines. Now, what I will do in the next few minutes is just to focus on few aspects that I found extremely insightful from the research agenda, and that of course are not exhaustive of the variety of insights that he provided during the lecture, but I think are especially fascinating. Now, the first perspective that I think is extremely interesting is this idea of infrastructures in cities as shapers of urban forms. And when I think about urban forms, it's not just the idea of urban expansion and suburbanization, but it's more what urban geographers would define the structural reproduction of inequality through urban spaces. Now, Edward has documented how, for instance, differences in the planning and in the implementation of infrastructural investments in road quality may generate hidden costs for some population groups with respect to others. I think in general, these insights lead to a more general research agenda that has to do with the implications for spatial inequality of the way in which infrastructures are planned. and implemented. And when we think about planning, of course, we speak about this dynamic relationship between infrastructural investments and land use regulation. Now, Edward Research has deeply engaged with this topic. And of course, the key insights we gather is that past durable structures affect the way in which network infrastructural layouts appear nowadays, but at the same time, current investments affect the way in which cities evolve over time, not just in terms of physical space, but also in terms of social fabric. When it comes to implementation, one of the key insights you may gather from Edward Research is this idea that we need to think not only about the purpose of infrastructure, but also the unintended consequences. And if I think about infrastructures with clear social cost and unintended consequences, one of the most interesting examples is probably the case of white flights cutting minority neighborhoods. Now, the US in particular is scattered with examples of infrastructure of this type. One of the most evocative one, which I recently had the chance to visit in person, is the case of Tulsa, Oklahoma, which is a city with a very peculiar history, because it was both the house of one of the most thriving entrepreneurial Black ecosystems in the beginning of the last century, and at the same time was also the theater of one of the most violent ethnic riots in the history of the US. So what is interesting about this example is the fact that around the 1960s, Greenwood, which is the house of the Black Wall Street, was involved in this large infrastructural project that basically cut the neighborhood in two. The results of this, high racial residential segregation and the hollowing out of the Black business districts in Tulsa. So overall, what I think we learn from Edward Research is that the timing, the type, and the manner of infrastructural development and maintenance matter not just for the shape of cities, but it also matters for the social fabric of cities and their demographic composition. Now, the second perspective that I want to analyze and that I actually found extremely fascinating is this idea of infrastructure as vehicles of physical mobility that map into economic mobility. Now, the quote that you find on the slide is taken from Edward TED talk in 2012. And the reason why I found it extremely interesting is because when we think about our own mobility decisions on a daily basis, whether to go to work or to work from home, whether to visit friends, the way in which we generally frame these decisions is in terms of the cost of distance. We rarely frame these decisions with respect to the benefits of the absence of distance, which in turn stimulates to reflect more about how much individuals actually move within cities, and in particular whether these movements and the geography of these patterns are different across demographic groups. Now, I think one of the most interesting insights of today's talk is this idea that different population groups move to a different extent. So Edward spoke about evidence regarding students, emphasizing how much lower income students not only move less, but also move in a more geographically constrained way. And that this is an antecedent to their future economic mobility in terms of prospects. Now, this idea that physical mobility mapped into economic mobility resonates with the research showing that individuals move more or less according with their demographic characteristics, for instance, education or gender, and that this heterogeneous mobility directly maps into economic outcomes, such as, for instance, career progression or wages. Now, this is a picture which shows in particular, how much individual moves according to gender in Milan between January 2020 and April 2024, so in the post-pandemic period, in a period in which opportunities to work from home, even without a direct agreement with the employer, were much more available. So what is interesting from this graph, where mobility patterns from residential location to work location are captured from cellular phone data, is that we do not see much evidence of heterogeneity in the geography of mobility between men and women for very short distances, but this differences unfold when distance increase, which imply that individuals internalize the cost of distance to a different extent according to their demographic characteristics. Now, if this is true, if there is heterogeneity in urban mobility according to demographic characteristics, and if physical mobility maps into economic mobility through a variety of channels, I think what Edward research really calls for is a deeper investigation of these patterns and the implications of these patterns. Let me then conclude with the last aspects, which I found very fascinating in his presentation, which is this idea of infrastructures and urban infrastructures in particular as platform for human interactions. Now, Edward started this presentation by speaking about learning cities, right? And this idea of learning cities map into the classic economic sociology view of cities about a mix of social infrastructures that favor the exchange of knowledge and the circulation of knowledge. Now, what is really interesting to see here is that when we think about cities as loci for interactions, and when we think about this mix of social structures, we speak about both workplace locations, but also about what we would call third places of social spaces. Now, I think one of the most interesting insights of Edward's talk, but also one of the most thought-provoking evidence, comes from the observation and a reflection about how much integration we do really see in these places within cities. Now, Edward has shown that when we look at integration on the job, there is evidence of strong educational segregation, with low-skilled individuals having limited possibility to learn from high-skilled workers due to this segregation. This research maps into research on urban entrepreneurial ecosystems, showing that, for instance, co-ethnic hiring is ubiquitous in new ventures. And in particular, it maps on Edward research about the shift in the use of public spaces. So this decline in spontaneous public sociality that comes from the fact that public spaces are increasingly used more as transit corridors than as actual social arena. So I believe that understanding this pattern, making a deeper reflections on this pattern is an important avenue for future research, is one of the very interesting insights that we can gather from Edward's research, also in the light of preserving the sustainability of cities as inclusive environment for diverse population. So I'll stop here and leave the floor for questions.